live before I continue onwards. So just give it a second. Okay, it is live now. Perfect. Okay, so what if in this triangle, instead of theta, I said, hey, can you find alpha here? So alpha is another letter I can use to represent a missing angle, right? So if I said, oh, alpha's here, this is alpha. So can you determine what the other sides are relevant to alpha? And so if this is alpha, the one thing that doesn't change is the hypotenuse. The hypotenuse stays exactly where it is. Like I said, hypotenuse does not change. That never changes. Okay, so the hypotenuse does not change. The things that do change are the opposite, however. So if we follow the rule for opposite, we go from the corner all the way across until it reaches the other side. The adjacent side for theta is now the opposite for alpha, which means the opposite for theta is now the adjacent for alpha. So depending on what angle you're looking at, your opposite and adjacent labels change, right? So it's very important, what angle are you talking about? And then label according to the angle we are talking about. If we don't label and we don't identify that, it screws us over completely, and we don't want that to happen. Okay, so we got to make sure, identify the angle. Step number 1, identify the angle. Step number 2, find the hypotenuse. Step number 3, find the opposite. And then step number 4, find the adjacent. That's usually the process I follow in kind of figuring out what your kind of your three sides are. So once again, step 1, identify the angle. Step 2, identify hypotenuse. Step 3, identify opposite. And then step 4, identify adjacent, which is the last side that you did not label. Okay? So once we have those down, now we know, oh, okay, that's what opposite means. That's what hypotenuse means. That's what adjacent means. Okay, so then we start figuring out what the 3 primary trigonometric ratios are. Big words, but essentially the trig ratios. When we talk about ratios here, ratios are another way we can identify or label fractions, right? Like if we say 2 girls to 5 boys or something like that, it will be 2/5 or 2/5, right? Ratios can be written as fractions, completely possible, right? So what we do here, we're saying the sine, cosine, tangent, their ratios are the fractions accordingly, right? So opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So when I ask you, hey, what's the trig ratio? I'm asking you, what's the fraction? Okay, what's the fraction? So when we go through this example here, state the primary trig ratios for angle Z. So where's angle Z? Angle Z is right here. So I'm going to identify the angle. Step 1, find the angle. I found it here. I'm going to label it as theta. Step number 2, identify the hypotenuse. I find the right angle here. I go across from that right angle corner, and that's going to give me the hypotenuse. I'm going to label hypotenuse right here. Beautiful. Step number 3, identify the opposite. We're going to go all the way across from the angle to the other side. That will be opposite. Perfect. And then step number 4, the missing side is adjacent right here. You should be doing this for every right angle question, right angle triangle question. Label, 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 right? Angle, hypotenuse, opposite, then adjacent. Label all 4 of those things. Once you have that labeled out, right? Once you have that labeled out, you can then continue to solve your problem here, which is state the primary trig ratio. So first, we're going to start off with sine. So sine theta is equal to SO, which is opposite over hypotenuse. So we have it on the top, but following our little saying here, opposite over hypotenuse. And so it just means, hey, what's the fraction? So you write down sine theta is opposite and opposite is 5, and hypotenuse is 13. Wow. Not bad. Perfect. That's your first one. Right? And since it says primary trig ratios, you have to state all of them. So then we move on to cosine, which is adjacent over hypotenuse. So cosine theta is equal to adjacent, which is 12, over hypotenuse, which is 13. Voila, there's our second ratio. And the last one, I'll have you guys do. So tan theta is opposite over adjacent. Give you 30 seconds to figure out this fraction. All right, you should be done. And we got some answers in the chat. And let's check those answers. Opposite is 5, adjacent is 12. So tan theta is 5 over 12. Perfect. So if you wrote 5 over 12, you are correct. Absolutely. Very simple, right? Once you're able to identify and label it, you can write down the numbers where they're supposed to go, and that's it. So if I ever say state the trig ratios, this is all you have to do, right? When it's stating, you just state what the ratios are. That's it. So what are the fractions? Done. Okay. Any questions or clarification before we move on here? I'm going to grab a quick bottle of water because I realize I don't have it. Oh, actually, no, I have another bottle here. I'm good. I was about to leave. I don't have to. Okay. Make sure you hydrate yourself, guys. 2 liters of water minimum every day. Okay. Then it says, use the primary trig ratios to find angle Z. Okay. So what does it mean to use the trig ratios? Well, this is where you need your calculator out. So I'm going to plug in my calculator here. Okay. And the hardest thing about today's lessons is that you need to know how to use your calculator. If you get the wrong answer, that's not okay. And the reason for that is because that's not you doing it wrong, right? It's you misinputting it in on your calculator depending on the phone you have. Certain phones, the way you type in trig, it's different. So if you have an iPhone, it's different from someone who has an Android, right? So I'm going to show you both ways of how to do it here. Okay. So I'm going to plug in my phone and make sure I'm on my calculator screen so you don't see my... What? What's up?
What if you're using an actual calculator?
If you use an actual calculator, you should be able to follow the Android way. I believe it's the same.
Okay,
If you have a 2-line calculator, it should be the way I'm going to show it on an Android phone. It's the same way. iPhone's a little bit different. If you have a single line calculator, you follow an iPhone. So if you have 2 lines, you follow the Android. So I'm just opening up my calculator on my phone so that you guys don't see anything else, like my lock screen or anything like that. I like my privacy. Okay. Does that launch? Perfect. All right. So we have our Android here. This is live from my phone, right? So I can start typing in a whole bunch of numbers and it should show up just fine. And then we're going to open up also our regular calculator here. So I'm going to have both of these ready. Okay. So the left one on the screen is the Android and the right one would be your iPhone. So this is kind of like the 2 calculators we're going to be using to identify how to calculate these values. So when it says to use the primary trig ratios to find angle Z, it is asking us to solve for theta. We need to figure out what theta is. And how do we do that? Well, we know in math, everything has an opposite operation, right? So we know the opposite of addition is subtraction. We know the opposite of multiplying is division. We know the opposite of squares are square roots, right? We have all these opposites in math. So there is an opposite for sine, cosine, and tangent. Okay. So what we do here, so I copy down sine theta is equal to 5 over 13. And the opposite of that, we want to isolate for theta. So one thing you have to realize, sine theta is like a gigantic group. This is one group. It's not sine times theta, okay? Sine theta is one huge group. You cannot separate those two by any regular means. You can't be like, I'm going to divide by sine. Like, that doesn't work, right? So sine theta cannot be different, like separated by any normal means through multiplication, subtraction, division, whatever you might think, right? Because it's one giant group, there's a special way to get rid of it. And the way we get rid of it is to do its opposite, which is sine inverse, or sine to the power of -1. And that's going to give us this weird little writing thing here. So sine inverse applies to the fraction. Okay? And that's going to give us our answer. So now the question is, okay, how do we do that? How do we do that on a calculator? Well, I don't know how this works. So let's figure that out. So on our Android phone first. So Android calculators here. You first turn your calculator sideways. Same for iPhones. Make sure you are horizontal, not vertical. Very important that you're using it horizontally, not vertically. Also take videos horizontally. That's a side point. Once you have this, you can exactly as it is written on the screen here. So first, you click your second floor or shift button. Your signs will change to sine inverses and cosine inverse and tan inverse. For those on a two-line calculator, look at what color your shift or second floor button is, and then look for the same color that says sine to the power of -1. That's the one you want to use. So I'm going to click sine to the -1. That gives me my sine to the -1 function. And then I'm going to do 5 divided by 13 and then close the bracket. Once we type that out, we get our angle. So that's going to be 22.6 degrees. So I'm just going to take it to the first decimal place here.
Yes, sir.
Yes.
How many decimal places do we need to put in?
Assume 1 decimal place. Assume
Okay.
1 unless I tell you otherwise. So we have 22.6 degrees. So just to kind of show you once again what we did here, right? This is what we did. Sine inverse, it can also be written as a sine, but your calculator should say sine inverse. Sine to the power of -1. Bracket, 5 divided by 13, close bracket. So that's for two-line calculators and Android calculators. For iPhones, you guys have it a little bit different. Okay? For iPhones, you're actually doing the fraction first. So you're going to do 5 divided by 13. Okay? Click equals. And you get this long decimal for your fraction. Then you go to your trig. You click second floor, find sine inverse, and then click equals. Okay? Whoa, sorry. Let's do that again. Okay? So second floor, sine inverse, and that'll give you your answer. So yours is a little bit backwards, iPhone users. A little bit backwards here. So you got to be very careful. For iPhone users, the fraction goes first, and then you do your trig inverse. Okay? Which also gives you 22.6. So what we're going to be doing for the next 5 minutes here, it seems like redundant, but we do need to do it, is practicing. Hey, can you type it in your calculator correctly? Because if you don't, you're losing free marks, right? We don't want you to lose marks because you misinputted on a calculator. That would suck. It's like, oh, I did all my numbers, I set it up correctly, and then you type it in your calculator and it's wrong, right? It's like, what? It's like, no, we don't want to lose marks there. You did everything right. You know how to do it. You know how to set it up. Then you should get the marks for setting it up, right? You should get the marks. So we don't want to lose the marks from the calculating part at all, right? So we want to get comfortable with actually being able to find this on a calculator. So the best part about doing this here is that when we do cosine as well, because we're all talking about the same angle, which is angle Z, right? Or angle Z, you should get the same angle when you do this. So if, for example, for cosine, when we do cos inverse of the fraction, we should once again get the same answer. So cos inverse of 12 divided by 13, what do we get? 22.6. Same thing for tan theta, which is 5 over 12. When you do tan inverse of 5 over 12, you should also get 22.6 degrees. Okay? All three of these, you should get the same one because we're talking about the same angle. Can I redo the iPhone one? Yes, absolutely. So for example, if I'm doing the cosine one for the iPhone, I divide the fraction first. So 12 divided by 13. Click equals. Okay? And then click second floor. And then I'm going to click cos inverse for this one because we're using cosine. And that's going to give us our angle here, 22.6. Okay? So make sure that's all good to go right there. So try, once again, all three of these fractions, all three of these ratios, convert them to the angle. If you get 22.6, great. If you did not, DM me and say, hey, could you help me fix this? I'm not sure what I'm doing wrong on my calculator, and I'll try to see what's going on. And we want to make sure everyone here is able to type in and solve for the angle correctly. That's important. Very, 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 very important. So take a couple minutes now, take around 3 more minutes to make sure that you get the right answer. If I don't see any questions, I'm going to move on in the next 3 minutes. I'm assuming everyone that is messaging me saying you didn't get the second one, 22.6. Are you guys doing, I'm assuming you guys are iPhone users?
I have a scientific calculator.
You have a scientific calculator. Wait, so hold on. Does the sine one work?
Never mind, I actually forgot to divide it. That's why. That's my fault.
So careful with your typing, right? If the sine one works, if you did sine and it worked, right? Then you got to be careful before you, and then just check what you typed in. So if you did the sine one and it worked, you just try it again for the cosine one. It should work. If you get the wrong answer for both, there might be something different on your calculator. So on your calculators, if you got sine wrong, cosine wrong, and you're thinking, I typed it in exactly as you told me, that means you might be having something called radians on. If it says RAD on your calculator somewhere, you need to change that to DEG, or it should not even say anything there. If it says RAD, you will get the wrong answer. That is not the form, that is not the units we are using. We are using degrees. It should say DEG somewhere on your calculator, or nothing at all. If it says nothing, that's good. Okay, so please double check that and then redo it.
How about for the tan one? It doesn't appear on an iPhone calculator.
What do you mean?
The
Tan inverse
last
should
one.
be there. It should be there. It should say sine, cos, and tan.
Oh, because I got a different answer every time I do it. That's the only one.
5 divided by 12, and then tan inverse. I get 22.6. So you want to make sure you process, right?
I keep getting 67.3 for the second one.
67.3.
Never mind.
You good?
Yeah, because I just kept pressing sine instead of cos.
Yeah, you want to make sure you click the correct sign, right? If you're using sine, you use sine inverse. If you're using cos, you use cos inverse. If you're using tan, you use tan inverse. So you want to make sure you're clicking the correct one, right? So this is why we take that extra time here to make sure we learn on the calculator, right? Okay. Okay. So let's move on here. I think most people have clarified their questions on the calculator, which is good. So I haven't had another question for a while. So we are going to move on. Let's try to solve for angle X this time. Okay. So for angle X, right, we're going to have to change our thing here. So I'm going to do it in blue. Angle X is up here. This is angle X. I'm going to call that alpha. Okay. I'm going to use alpha here. Hypotenuse doesn't change. We talked about that, right? The position of the hypotenuse does not change. However, opposite and adjacent do. In reference to alpha, opposite, and this is now adjacent. Okay? So in reference to alpha, where alpha is, if I give you a question, find angle X. Just find alpha. Okay? You can pick whichever trig ratio you want to use. Do you want to use sine? Do you want to use cosine? Or do you want to use tangent? It doesn't matter. Okay? It really doesn't matter which one you want to use because in this case we have all three sides. So pick one, right? So pick a trig ratio you want to use. So should we use sine, cosine, or tangent? What's the vote? Like I said, it's equivalent. Doesn't really matter.
Sine.
Perfect. I heard sine, and Sydney said sine too. Perfect. So we're gonna use sine. So we know sine alpha. I'm gonna use alpha. It's equal to, and we look up opposite over hypotenuse. And for us, sine alpha, opposite is 12, hypotenuse is 13. And so when we calculate that, we want to solve for alpha. So we want to get rid of sine by doing sine inverse of the fraction. So one more time. Everyone should get this, right? So on Android here, oh, my phone locked, and you guys are going to see my background. Sine inverse of 12 divided by 13. Okay. So on Android, just typing exactly as is gives us 67.4. And on iPhone calculators, 12 divided by 13 equals second floor sine inverse 67.4. So we get the exact same answer, which is what we want. So make sure you try this question here, type it in correctly, make sure you get the right answer so that we may move on to the next question, section here.
Mr. Choi,
Yes.
what's the difference between that sign and the beta? I don't know what to call this. This 0. Oh,
Uh. Oh, you mean this like on the screen here?
yeah, and here in
Oh.
find index and sign this one.
Yeah. So, are you talking about the difference between regular sine versus sine inverse?
No, I think she's talking about like see the how it equals sine -1. Yeah, before that little squiggly thing,
This
like
thing right
right
here.
there. See where
Yeah.
you pointed the arrow? Oh wait, I don't know.
So this here is just a letter. So alpha is what I use to represent angle x. Because we already use theta, we don't want to use theta twice, right? So I'm using another letter to represent angle x. So in this case, I used alpha. So that's what that is.
Okay.
Yeah, it's just another letter to represent it, so that we don't get confused. Because if I use theta, then it gets confusing. It's like, which theta are you talking about, right? So when we're talking about two different angles, we use two different letters. Like we would use like x and y for two different variables, right? So that's the idea. Okay. What I like now is that chat is silent, which is good. No one has any questions about this calculation, which means I will assume that most people have gotten the answer on their calculator, which is great. We want to make sure we get these answers, like I said, right? You don't want to mess up your math on a calculator because that is not great, right? It's like you lose a mark for getting it wrong by typing it in a calculator. That would suck. We don't want that, right? Okay, let's continue onwards. And like I said, the second thing in math that most people remember after SOHCAHTOA is the Pythagorean theorem. A squared plus b squared equals c squared. The same rule applies for the Pythagorean theorem, though. The most important part that you want to identify is the hypotenuse. The hypotenuse is super important because that's the one that never changes. Hypotenuse is c. Okay? The hypotenuse is c, nothing else can be c. C is specifically set to be the hypotenuse. So as a result, when we have the Pythagorean theorem here, a squared plus b squared equals c squared is locked to be the hypotenuse. A and b could be any of the other two sides, doesn't matter which one, right? But c is specifically the hypotenuse. So when we look at a right angle triangle, like I said, identify the angle, identify the hypotenuse. There's a reason why those two steps are first, is because you don't want to mess up finding the hypotenuse. Because if you mess that up, your whole question's wrong. And that would suck. So, it says here, hey, find the length of the missing side, then find the measure of the missing angles, round the answer to 1 decimal place. So this is going to take a little bit of time. I'll do one question, and you can do the other. Okay? So I'm going to do question 2, because that's the easier one. Okay? So, first, we're going to solve for the missing side. So let's call it, instead of calling it question mark, right, let's call it x. We don't know what x is. So the first thing we want to do is identify the hypotenuse. So since this is the right angle here, the hypotenuse is over here. Okay? So that's the hypotenuse. What that allows us to set up right away is our Pythagorean theorem. So a squared plus b squared equals c squared. And we can now solve for our hypotenuse. So we plug in the values. A and b could be any of these numbers. You can pick which one's a, which one's b. It doesn't matter. So I'm going to say a is 5, b is 13, and c is x, right? That's the hypotenuse. I'm going to plug that in there. Then I solve it. So 5 squared is 25, 13 squared is 169, and then x squared is x squared. We combine these two here, we get 194 is equal to x squared. And then we can square root that on both sides to get rid of the square. And so pull out my handy dandy calculator here to do my square root. So if I square root 194, I get 13.9 approximately for x. Okay? So we get around 13.9. Okay. That's the first part of the question. See how it says round the answer to one decimal place. So 13.9. Okay. Sorry, something's in my eye. Okay. Then it says find the missing angles. Okay. When you're finding the missing angles here, pick one angle you want to work with. Doesn't matter which one, pick it. Okay, I'm going to find this one. I'm going to call this theta. So I'm going to label theta here. I'll say this is theta. I choose this to be theta, which means we can say this is opposite and this is adjacent. Okay? Now, the one thing you have to do now here is pick. Do I use sine, cosine, or tangent? Most of you will be like, I'm going to use sine because we'll keep using sine. But in this case, you actually don't want to use sine. The reason is because we had to solve for the hypotenuse. If we have to solve for it, not a great idea to use it. Tan is the one you want to use. So tan theta is opposite over adjacent. And the reason for that, and Lorraine typed tan in chat as well, and the reason for that is because we have opposite and we have adjacent, right? These are values that were given to us from the beginning. So since they were given from the question, we want to use those values, and the ratio that uses both of them is tan, opposite over adjacent. So when we write this out, we now plug it in. Tan theta equals opposite over adjacent. 5 over 13. And then tan inverse. Oh, sorry. I should write theta equals, sorry. Theta equals tan inverse of the fraction. And once again, doing that on my calculator here, handy dandy calculator. Tan inverse of 5 divided by 13 gives me theta is 21 degrees. Okay. So we get 21 degrees here. Okay. Make sure you get that here. Now we're not done. We need to find all the missing angles. That's the tricky part. We need to find all the missing angles. So if we need to find all the missing angles, we're going to have to do some extra work. We need to solve for alpha. How do we solve for alpha? There's a couple different ways. You can do trig ratios again, but there's an easier way than that. Anyone know? What's the easier way to solve for alpha?
Is it the 90 degrees minus 21?
Yeah, well, not minus 21, but you're close. I do know what you're trying to say.
Oh,
180 minus 90 minus 20. Yeah, so the three angles in a triangle add to 180. So if we subtract the other two, we should get our final angle. So you don't actually have to do trig for the last one. You can just quickly do this math. So 180 minus 90 minus 21 is 69 degrees. Okay? So this would be the full solution to one of the questions here. All right? So this is when you solve a triangle. You need to find all the missing sides, all the missing sides.
Where did you get the 180 again?
The three angles in a triangle add to 180.
Oh, okay.
That's the triangle rule. So we want to keep that in mind, and we can just subtract. So
Okay.
I'm gonna give you around 5 to 7 minutes to solve for triangle 1. Please be careful when you use. I'm gonna give you this tip now because some people might not remember, right? C is the hypotenuse, right? If C is the hypotenuse, this is not C. This would be like A or B, right? So you have to rearrange before you solve it. So please keep that in mind when you're doing this. Okay? Otherwise, I'll give you, once again, 7 minutes to do so, and then we'll take it up.
Sorry, wait, I have one more question. See, why did we use tan in that equation? Because we found the hypotenuse, right?
Yes, we did find the hypotenuse, but the reason why we used 10 is because we solved for the hypotenuse. If you made a mistake there, then you're going to use your mistake, right? By using 10, we avoid using our mistake because we use values that the question gave us.
Okay, thank you.
No problem. Okay, so 5 to 7 minutes, and then we'll take it up. If you have any questions, type it in chat, and I'll try to answer it as soon as possible. Okay, I'm gonna give you a couple minute or two, like a minute or two to finish off. It is fairly long, right? The process is a little bit long, but it does give you the practice that you require for it.
Mister, we could choose any of the three, right? Does it matter sometimes, or
For sine, cosine, and tangent,
Yeah.
sometimes it doesn't matter if I give you all three sides, but for this one, you should be using a specific one, depending on which angle you chose. And I'll go over it.
you'll go over like why should we choose that sign or something?
I'll review that. Yes, I did talk about it, but I'll review it in case you missed it.
Mister,
Mm-hmm.
I have a question. So, in Pythagorean theorem, can I use the formula that like A is equals to square root of C squared minus B squared?
Yep, that's what you should be using for
Okay.
this question. Okay, so let's take it up here. So what Lorraine was mentioning just now was to rearrange the equation earlier. So you can actually just rearrange this right away to c squared minus b squared. So for those that don't know, this is the Pythagorean theorem for finding hypotenuse, right? So solve hypotenuse. And then this would be the one where you solve for the side, right? So you choose the which one that you want to see. And Angie, we will check your answer. We will double check that answer, don't worry. So here, for question 1, if we do that side work here using a squared equals c squared minus b squared, and we know that this is the hypotenuse here, okay? We plug in, we get a squared is equal to 19 squared minus 17 squared. And so 19 squared, we get 361. And then 17 squared, we get 289. So subtracting that, 361 minus 289 gives me 72. We square root both sides. And we get a is equal to the square root of 72. So clearing 72, and we square root that. We get 8.5. Rounded to the first decimal place, so 8.5. All right, so that's A. So we got our first answer there, right? Which is our missing value here. So I left that as A. You can, if you put X there, that's fine. So that would be our missing side here. The second part here, it depends on which angle you picked. Some people I see already picked this as theta. Some people picked this as theta. It doesn't matter which one you picked. If you picked this one as theta, you would have gotten adjacent and opposite here, which means you used cosine. If you picked theta here, this is opposite and this is adjacent, you would have used sine for your equation. So, once again, I'm just going to pick the one that I usually prefer doing. Doesn't mean yours is wrong or it's a mistake. It's not. It's right. If you picked this one, that is just as right as me picking this one. Okay? So I'm going to pick this one. That's usually the one I prefer using. Not because it's like it's better. It's literally just I just like visually having it there for some reason. So this would be adjacent, this would be opposite here. And we have adjacent and hypotenuse. So the one that uses that is adjacent over hypotenuse. That's cosine. So solving that out, plugging in the values, we get adjacent is 17 over 19, right? The opposite of cosine is cos inverse, and that's when we solve for the angle here. So we get 17 divided by 19, and we can solve that. So on my handy dandy calculator, cos inverse of 17 divided by 19 is 26.5. So we get 26.5, which means if I call this part here alpha, then alpha is going to be 180 minus 90 minus 26.5. And doing that math is going to give me 63.5. So these are the two angles I get here. Okay. I see Angie wrote you got 63.7, 29.3. I think you guys pretty much got it. I think it's just a 0.2 difference. I'm not sure where that 0.2 difference came from. Yes. When you do sine, you are going to get 63.7 instead here. So it's just going to be a rounding difference. So both answers would be correct. So if you got 63.7 and 26.3, if you did the upper angle first, that is still right. Okay? Yes.
How would you know if you're gonna use this one, the C minus B, and the other one that we did in number 2?
I already wrote it down. I said you use this if you're solving a side, this if you're
Okay.
solving a hypotenuse. Yeah. So top one if you're solving hypotenuse, bottom one if you're solving for the side. So yes, there will be minute differences in decimals depending on which angle you solve for first, but it should be minor, not a huge difference here. So I get 63.5 either way. I think I get 63.5 both ways, regardless of which way you do it. So just check your rounding. Just double check on that rounding. Be very careful. Okay? Otherwise, that was our review lesson. That wasn't even the actual 5.1. But 5.1 uses a lot of this review concept. So it's not like we did this for naught. So we are going to continue onwards here. Are there any final questions? You guys have been asking very good questions and clarification. Always welcome, right? Okay. No questions. So we're going to be moving on to 5.1. Now that we know SOHCAHTOA, can you solve questions? Okay. So let's go through this. Okay. So there's two pieces of terminology that you need to learn or remember. It's the angle of elevation and the angle of depression. So this is kind of how I explain it, right? So bear with me here. I'm going to stop sharing my screen so that you can see me, right? So if you see me here, let me try to mute that real quick. I'm trying to make sure that you guys can just see me. Just give me a second. As I double check on YouTube, making sure that it's just me, or you can just see me. Okay, cool. So what's gonna happen here is essentially we have kind of like this situation here. So let's say I'm standing on the ground here, right? Let's say I'm standing on the ground. I'll make this focus upwards a little bit. So let's say I'm standing on the ground here, and I'm looking at you know, a situation where you know, you are trying to look at someone up at a cliff, right? If you're looking up towards someone, right? The issue here is that if you are a, you know, natural person, I'll use natural. If I'm looking up towards a cliff, right? I don't look at the sky and then figure out where the person is. That is unnatural. That's not normal. That's not what we do, right? When someone says, "Hey, look up here," you don't look at the sky and then figure out where they are. That's weird. Why would you do that? Right? When someone says, "Hey, look up here," what happens naturally? Your eyes start from the ground or the lower level and it scans up until you see the person. That is your natural reaction to figuring out when someone is up on a cliff. You get what I'm saying? So that is the angle of elevation from looking down all the way until you meet the person. That's the angle of elevation. So look at how I'm doing it. Look down and up. And that angle that I just made here would be the angle of elevation, right? So do you get that concept there, right? The opposite, right? Let's change the slide here. The opposite is this. If I'm on the cliff and I'm trying to find someone that's below me, right? I don't look at my feet and then look up to find the person. That's weird to me, right? I don't look down at my feet when I'm off the cliff and then look up until I find the person. That's weird. What do we naturally do? We look straight across the horizon and then we scan down. You get what I'm saying? So we look across and then down until we find the person. That is the angle of depression. So once again, looking straight across and then down when we look for someone, when we're on top of a higher building or a higher cliff or something like that, we look straight across and then down. That's the angle of elevation, or sorry, angle of depression towards what you're looking at. So it's very important that you know that distinction. Elevation, look at the ground up, right? Looking at the ground up. So horizontal up. Depression, we look across and then down. So it's a very distinct difference, but it's really important because some people get this angle wrong. If I just say, hey, this is the angle of elevation or this is the angle of depression, they indicate it incorrectly on their diagram, which makes you lose marks. So as if you remember this kind of picture of you standing where that person would be on the cliff or on the ground, it helps you kind of identify and figure out where the angle should actually go, right? So hopefully that was a little helpful in determining like where the angle of elevation and angle of depression should go. Okay, so hopefully that was a little bit helpful. So what we're gonna do is share my screen again. And so here, when we talk about angle of elevation, it says you're out in a field, you're flying a kite, you have just let out 150 meters of your kite string. You estimate that the kite is at an angle of elevation from you at about 20 degrees. So since it, once again, mentions angle of elevation, you are on the ground and you're looking up towards the kite. So this would be the angle here, and it's indicated. But if the angle wasn't there, you should be able to figure out where that angle goes on your diagram. Does that make sense? Right? So it's very important that you're able to identify these things. So that's going to be 20 degrees. So that's our angle of elevation. And it says calculate the height. So that would be X here. Okay. So you'll notice we have our angle, we have our hypotenuse. We know this is hypotenuse, right? 90 degrees across. and we have x. So I'm going to label that actually in black. So we have hypotenuse, we have our theta, this is our angle, and we have x. What is x in reference to the angle? Anyone want to type it in chat? Is it opposite, hypotenuse, or adjacent?
Opposite.
Perfect. Opposite is correct. Because this is theta, we go straight across. That would be our opposite side. So we write down, we think, okay, I have hypotenuse, I have theta, I want opposite. Which trig ratio uses opposite and hypotenuse? Sine, cosine. So, could you repeat that?
Sine.
Sine. So sine theta is equal to opposite over hypotenuse. So it uses both, right? And so we're going to work with sine. But in this case, it's not that we're solving for an angle, we are solving for a side. So let's take a dive into how we can solve for a side. When we have it here, we plug in all that we know, and we plug in sine, and we have theta this time. So we're going to put bracket 20. So sine 20 is equal to opposite, which is x, over hypotenuse, which is 150. So now we're solving for x here. We're not solving for theta, we're solving for x. So what's going to happen here is that we're going to get rid of the 150. And how do we get rid of 150?
Divided
How do we get?
side.
Could you say that again, Angie?
Divided.
By 20.
Multiply by
Sine 20.
no 150. So guys, just to clarify, yes, normally you would think that you want to get rid of sine 20, but remember, we have everything here, right? We know what this is. We want to work with this. We want to make this alone, right? In algebra, if we don't know x, we want to make sure x is alone. So we're actually getting rid of the 150, and we want to move it this way. And to move it, well, 150 is dividing, so the opposite is
Multiplying.
multiplying. So that's going to give us this here. And the question that I usually get here is, why do we put the 150 in front? Can't we just write sine 20 times 150? And yes, you technically could, but the reason why we don't do that is because some people do this. Do not write this down. This is in purple. Don't write this down. People do this. They don't use the brackets, and then they do times 150. And then what happens here is then they do, oh, this is sine 20 times 150, so this is sine 3000. And I'm like, that's wrong. Don't do that, right? So in math, when we have sine, right, if we're multiplying it by a number, we actually put it in front so that we actually don't mess up our notation here. So this tells us 150 times sine 20, right? Because this is a group. You can't touch anything inside of it. You solve this first before you multiply. So this will allow you to get your answer. And once again, same idea here. Make sure you get the same answer as I do on your calculator. So on an Android phone, once again, we're going to do 150. I'll bring it up on the screen, sorry. 150 sine 20. So we're not using sine inverse this time. We're just using regular sine. So 150 times sine 20 gives me 51.3. And we have the units, which is meters. Okay. For an iPhone calculator, there's two ways you could do it. You do 150 times, and then you type 20 sine, and then equals. Okay, I'll say that again. You do 150, which is in front, times, you type what's inside the sine, which is 20, then you click sine, then you click equals, and that will give you your answer. That is your
Do it
first
again.
way. Yes, I can do it one more time. 150 times, so that's the beginning. Then for the trig part, you do the opposite way. So you do 20 first, then click sign, then click equals. So that's your first way of doing it. The second way you can do it, you can do the trig first. So you can do 20, then sign. Okay. Okay. Then multiply by 150. And you will get your same answer. Pick iPhone users. This is why you should get a scientific calculator. If those who have a scientific calculator have it much easier at this point, right? Get a calculator if you haven't gotten a calculator. Type it in. I'll give you around a minute or two to try typing it in on your calculator. Make sure you get this answer before we move on. Okay, so you should get 51.3 meters. Okay, and we can write our therefore statement. So I'll just write that as you guys are solving. Therefore, height is 51.3 meters above the ground. And there it is. Okay, I'm assuming everyone has gotten it, so we will move on. There are no questions in the chat, which is great. So then we're going to move on to here. The communication antenna is attached to the roof of a school and held in place with two 60-meter guy wires. The antenna is 12.5 meters tall. What angle of elevation from the ground do the wires make with the roof? And then B, how far apart are the points at which the guy wires meet the ground? Okay, so if it's asking for angle of elevation, is it angle A, B, C, or D? Ask for angle of elevation, is it A, B, C, or D?
From B looking to A.
B looking to A, yes. This angle here would be our theta. Okay, it's angle B. So angle of elevation is looking from the ground horizontally upwards to the top, right? So that's angled theta. So that's angle of elevation here. The same could be said for C. You could say this is also theta, which is true. It is an isosceles triangle. But once again, this is theta. We're going to work with that. It's already labeled for us too. Hypotenuse, opposite, and adjacent. So it's actually all labeled for us. So we're good to go here. So what are we given? We're given opposite, we're given hypotenuse, and we need to find theta. So if we're given opposite and hypotenuse, what are we using? Sine, cosine, or tangent?
Sine.
Good, we're using sine again. So sine theta is opposite over hypotenuse. And this time we don't know theta. So we solve this the regular way. So I'm going to leave it here. I'm not going to solve for theta. I want everyone to figure out what theta is, and then on the count of 3, I want you to type it in chat. So I'm going to give you a minute to figure it out. Okay, I'm going to give you a minute to figure it out, and then we're going to solve out what theta is. You're going to type it out. This is to make sure everyone is able to do the division. Okay. So you should get an angle. On the count of 3, type it in chat and send it to me. 1, 2, 3. You can DM it. I have a couple of people DM me. I have a couple of people typing in chat. Nice. Most people, I think everyone who sent it got it. It is 51.4 if we round to the first decimal place. Right? So for those that wrote 51.3, just make sure you round. Otherwise, you did get the right number. 51.3 is right. It's not wrong. Okay? It's not a mistake. 51.3 is right. You just want to make sure you round. So this is 51.4 degrees. That is what you should have gotten.
Sorry, I got a wrong answer.
How did you type it in your calculator?
So I put sin, and then I put 12.5, and then
Did you forget to
divided by
do sine
15.
inverse?
Oh, I didn't do that.
You're doing the opposite. Yeah. So try doing sine inverse. So that is correct. So you are doing sine, but you want to make sure you do sine inverse. So everything else you typed was correct, Angie. So you're good. So just make sure it's sine inverse. You should get 51.4.
Okay, got it.
Perfect. Nice. So everyone has the answer, which is great. So then, part B, how far apart are the points at which the guy wires meet the ground? So it's asking us for the distance between B to C. So it's asking us for this whole distance here. But we probably don't want to, solve for this whole thing, right? There's an easier way of doing it, which is to separate it into a half section, because it should be the same half. If this is x, that's x, right? So we're going to solve for this section here from B to D, because we can double that for D to C. It's going to be the same distance, because it's exactly half. There's 2 ways you can solve this. You can solve this using the Pythagorean theorem, or you can solve this using your angle that you calculated. I don't care which one you use, okay? If you want to make sure that you did not make a mistake, the safer route would be the Pythagorean theorem. If you are confident in your angle, you can just use that to calculate your side here, okay? So it is up to you. I'm going to show you how to use the angle itself. So for me, I'm going to say, okay, I know that theta is 51.4 degrees. So I'm going to use SOHCAHTOA to find my adjacent side. It doesn't matter which one we use. Let's use one we haven't used yet, which is cosine. So I'm going to use cosine. And I'm going to say adjacent over hypotenuse, because we need to use adjacent here. We need to find that. So let's say adjacent, let's call this x. So if we plug that in, I'm going to get cosine of 51.4 is equal to x over the hypotenuse, which is 16. We run into the same thing again. We want to move the 16 to the other side. It is dividing, so we will multiply. And we're going to get 16 cos 51.4 is equal to x. Okay? So same thing, one more time. I'm going to give you a minute to calculate your x value here, and then we're going to check our answer. Careful now, this is not this is not inverse, this is regular cos, because we are solving for a side. So type it out, solve for it, and let's take it up. 1 minute. All right. On the count of 3, type it in chat. 1, 2, 3. Okay. So the people that wrote it down as 10, you are correct. If you wrote 9.98, that is correct as well. Just remember to round. If you round it, it will become 10. So 9.98 is correct. Just make sure you round. And I know I saw someone wrote 20, so we are going to get there. So that was the actual final answer. So x itself is 10. We are only solving for x for now. And then we can double it for our final answer. So since both sections are x lengths, right? Therefore, the guy wires are 20 meters apart. So the final answer, like Brooke was saying, is doubled because, as you can see in the diagram, it is double the distance of x. So that you should say the guy wires are 20 meters apart. Okay? So perfect. If you wrote x equals 10, that's great. You did get the right answer. If you did not get 10, double check how you typed it in your calculator. You might have just misinputted something by accident. So just double check that. All right?
Okay, I have a question. So
Yes.
this might seem dumb, but like, how do you know when to use cosine and sin and like tan? Like you explained this before, but I still don't get it.
That's not a dumb question. Why do you think it's dumb? There's
I
no
don't know.
dumb questions unless it's not like I said, there's no dumb questions, there's no stupid question unless it has nothing to do with the lesson. Then it's dumb because it has nothing to do with the lesson. So the adjacent and hypotenuse. The reason why I use cosine, I didn't have to. So you're probably confused at why cosine, why can't we use tan? And you'd be absolutely right. You can use tangent. You can absolutely use tangent here. I just used cosine because I wanted to. If that's your question. You can use tan because we have opposite already as well, right? The only thing that locks you down, you can't use sine because we needed the adjacent, right? So as long as you use a trig ratio that includes adjacent, you're good to go, right? So
So
whether you use cosine or whether you use tangent, you should still get the same answer.
okay, so basically like the value you find, like whatever the adjacent, whatever sorry, not the adjacent. Whatever you find, you need to use that in your equation, right?
Yes, you need that, exactly.
Okay.
When you're solving for your angle, though, like when we did here, you better be using the two sides that are given to you, right? I think that's pretty obvious, right?
Yeah.
So, but when you're solving for a side, you want to make sure you include what you're solving for, or else you're not solving for it. So that's the idea there.
Okay, thank you.
No problem. Okay. So that was 5.1, right? some word problems diving into, our trig. We're almost done, guys, I promise. Once again, we said we're going to be going for those 2 hours, no break, and then you guys get the rest of the day off, right? So for 5.2 here, solving problems using right triangle models, it's the same thing, but we're going into a more difficult problem here, right? More difficult word problems. So what I'm thinking of doing here might even be a slight homework check just to see, just like one question that you can do for the asynchronous portion. So I'm going to do example 1. I'm going to give you how to start example 2, and then I'll put this as a homework check here. Okay. So chapter 5.2, solving problems using right triangle models. This is essentially saying, okay, now let's take those problems and make it slightly more difficult, just a little bit, where you're not always given a diagram or you're not always given a right angle triangle, but can you convert it into a right angle triangle? So over here it says Karen is a photographer taking pictures of the Burlington Skyway Bridge. She is in a helicopter hovering 720 meters above the bridge, exactly 1 kilometer horizontally from the west end of the bridge. The Skyway spans a distance of 2,650 meters from the east to the west. Okay, now, that being said, don't even read part A, part B. There's no point going there yet. Draw it. Can you draw this diagram? Is the question. Okay? So first, we have our helicopter up here. I can't draw, so I'm not going to draw a helicopter. So we'll say this is Karen. We'll call this K. Karen is up in the sky, and she is above the bridge here. If we draw the bridge, maybe it's more like this or something like that. And here, right, it says she is 720 meters above the bridge. And this section here, if this is the west end of the bridge and this is the east end, it says here that this section here is 1 kilometer. It also tells you that the whole section here, or the gigantic from east to west, is 2,650 meters. Okay, so this is what you should have drawn here. You can also, of course, finish off this drawing by drawing your triangle. You can kind of see that here, right? And you can kind of see that there are the right angles as well in this triangle. So if you'd like those in. So when you start these diagrams, it is very, very, very important that you are identifying what the diagram looks like. This is going to be the hardest part about solving these problems, right? Once the diagram's down, what you figure out should be much simpler, right? So I wrote all this information down. I wrote everything that they gave me. So now let's change up the information that I know. So I'm going to kind of make my life a little bit simpler. And knowing this information, I'm going to draw another point here. I'm going to say this is 1,000 meters. And this here is 1,650 meters. Does everyone see how I got that? Right? 1 kilometer converted to meters is 1,000 meters. And since the whole highway, the whole bridge was 2,650, if I subtract the 1,000, I will get the leftover here. Okay? So, once we have that here, we can then actually solve for our actual question. So from part A, from Karen's position, what are the angles of depression to the nearest degree of the east and west ends of the bridge? And those, if I draw that on our diagram, would be here. So if I draw kind of like a horizontal, flat horizontal line, dotted line. Let me actually draw a dotted line here. So if I draw a dotted line going across like so, you can see how this diagram could get kind of messy here if you don't neatly draw it. Essentially here, we're saying it's asking for, hey, what's theta and what's alpha? These are the two angle of depressions it's asking for. Okay? Now, two ways you can solve this problem. Okay? Two ways you can solve this problem. Does anyone remember the parallel line theories? The C rule, the Z rule, the F rule? Anyone remember those?
Kind of. Yes.
Kind of, right? The
So,
F rule saying, you know, the angles inside are the same. Z rule saying the angles inside are the same. So on and so forth, right? Let me give you a little bit of a hint here, or a little bit of an advice. If this angle of depression is theta, the angle of elevation is also theta. The angle at which someone looks up should be the same angle at which someone looks down. So this is theta. And this here then would be alpha. So instead of figuring out, oh my gosh, that's not even part of the triangle, don't panic. It actually is. The angle of depression is equal to the angle of elevation. So this is actually also theta, and this is actually also alpha, which actually breaks our triangle to be much easier like this. But I'm going to keep that there just so that people can see. Okay? So this is part A. Drawing the diagram takes majority of the time, right? Drawing the diagram is a pain. It really is. I'm not saying it's not, right? But it really helps you identify like, oh, okay, now I know what I need to solve for. Now I know what I have, what I can use, right? So what you can do now is something really nice, which is I'm solving for alpha, I'm solving for theta. I have my overall diagram. That means I can actually solve for my triangle separately. I can call this theta and fill in my values. And I can draw another triangle like this, call this alpha, and fill in my triangle. And notice how much nicer and cleaner you're able to identify your pieces of information once you have your diagram down. I've just broken up my original diagram into two separate triangles to make sure it's not cluttered, I'm not confused about my information. So I can now figure out what theta and what alpha is. Okay? So that's what we're doing here. Okay? Now, from here, we're trying to calculate it. Do I use sine, cosine, or tangent? Actually, I'm going to make this a poll. Hold on, give me a sec. I think that'll be more fun to do. Let's make a poll. Okay, so I'm going to put the poll up. So let's say I'm solving for theta. Which one do I use, sine, cos, or tan?
Mister, where did you got the 1650 again? I forgot.
So the whole bridge is 2,650 meters, right?
Yeah.
And then it says the west side of the bridge to the helicopter is only 1,000. It's a 1 kilometer. If you
Okay.
subtract,
Yeah.
you get 1,650. Okay. For those people that are not sure, make sure you're labeling. So even though I didn't label here, you should be able to do this. With these labels, I'm going to redo it. So those 5 people that are now not sure, I want you to take a look at the labels. I want you to re-vote, please. Which ratio do I use? Look at what we have here. Okay, another 10 seconds. Okay. Majority have people have picked 10 as their answer, and 10 is correct. This would be tan theta. I'm going to zoom in here, sorry. So this is question A. So tan theta is equal to opposite over adjacent. Those are the two sides that we have. So we're using tan, right? We have opposite, we have adjacent. So opposite over adjacent is what we want. And so when we plug it in, we're going to get 720 over 1000. Okay? And the same thing's going to be true on this side, actually. If this is alpha, this is also opposite, hypotenuse, adjacent. Turns out we're doing tan twice. So tan alpha is equal to opposite over adjacent. And it's going to be the same process. So we're going to be doing tan inverse. So theta is equal to tan inverse of the fraction. Same thing on the other side. We're going to get alpha is equal to tan inverse of the fraction. And let's type this in on a calculator. So plugging it into my calculator here. Oh, 1 second. It is locked. Okay. So tan inverse of 720 divided by 1000. And I get 35.6 for theta. And for alpha, I get tan inverse of 720 over 1650. Oopsies. Is 23.6
Mister,
degrees. Yes.
I don't know why did I got 35.7?
It should be 35.6 because it's a 7 and the number after is a 5. Oh, sorry, 35.8. Sorry. I completely read that wrong. I meant 8. That is correct. Sorry.
I
Good
got
catch.
36.8.
I got 35.8. You sure it's 36?
I also got 35.8.
35.8 is what you should get. So just to bring it up on the calculator again. So tan inverse of 720 divided by 1000. I get 35.8.
Oh, I don't know why I thought it was 750. My bad.
It's all good. So it's 720. So 35.8 degrees. And then tan inverse for the alpha should be 23.6. Okay? So then we can write our therefore statement, like therefore the angle of depression for the east and the west are 23.6 degrees, and I can't write the degree sign, so I'm just kind of writing degrees, degrees respectively. Okay, so that would be your sentence. You can write the angle of depression for the east is this, angle of depression for the west is that. I just put into one sentence, so if you would like to do that, you may. So that would be part A. A is long, right? Not saying this is an easy question. It is getting more and more difficult, of course. That's the idea, right? So this would be how you solve for the two angles of depression, right? Because angle of depression is equal to the angle of elevation. Now, that brings us to part B. If Karen's camera has a wide-angle lens that can capture 150 degrees, can she get the whole bridge in one shot? How do you figure that out? I'm going to zoom out to look at the diagram. How do we know whether or not she can see the whole bridge in one shot? What angle are we looking for? Anyone know?
Is it the angle from the top of the triangle?
Bingo. Yes, it is this angle here. I'm going to call it beta. Okay. Let's call it beta. It's like a curved B. I do terrible. Beta is like a letter I can't really draw well. But beta will be our third angle up here. So that is actually going to be our last angle. So if that is at least 150, she can see it. If it's greater than 150, she cannot see it. So we're going to say, oh, beta is equal to 180 minus 35.8 minus 23.6. So we are looking at the gigantic triangle here. This, wow, that is terrible. So we're looking at the gigantic triangle here, right? Using beta, theta, and alpha. In doing so, just subtracting it, we get 180 minus 35.8 minus 23.6. Oopsies. Which we get 120.6 degrees. So can Karen see everything? Yes, Karen can see the whole bridge because the minimum angle required is 120.6 degrees. And that's going to be this. So she needs at least 120.6 degrees to see the whole bridge. 150 is way over that. That should be no problem. All right. Any clarification or questions about this, right? This was one question, right? You got to remember, this is one question. So it's really important that you get your questions answered here, right? Drawing the diagram is the most difficult part. Once you draw the diagram, everything starts to boil down very simply to SOHCAHTOA and then finding the angles, right? Or finding the sides. So make sure you're able to set up your diagram correctly. That's really important. Okay? Okay. So, looks like there's no questions, which is great. Maybe I'm wrong in assuming this, but so far it looks like people are starting to grasp this concept. So it's almost 11. I'm going to guide you through question 2 here. Okay. This is not a right angle triangle. Obviously it's not, right? This is clearly not a right angle triangle. Okay. But does that mean you can't make it into a right angle triangle? Absolutely not. So if I draw this vertical line straight down and make this kind of 90-degree angle right here, we can get a right angle triangle. And why that's important is because it asks us to find the area of the lawn. And to find the area of the lawn, you need the height of the triangle. And thankfully, the height of the triangle makes a right angle triangle. Right? So we need the height. So if we draw out a right angle triangle like this, you can solve for the height. So then we can label, oh, this is hypotenuse, this is opposite here, where the H is opposite. And then this would be adjacent down here, not the 11, but from here to here would be adjacent. Then you can solve it. So if we were to redraw the triangle that we care about, it would look something like this. We have this triangle here. We have the 90 degrees, H, 13, 40 degrees. So you can redraw what you have and then solve for that. For those that don't know the area of a triangle, area is equal to base times height. I'm going to write it down here, sorry. Area is equal to base times height. Whoopsies. Oh my. Divided by 2. That's going to be the area. Okay. So that should give you a hint. Solve for height, and then plug in to your formula to solve for the area. Then once you have that, you can solve question B. So that's my starting point for you for this question here. So I'm going to leave that on the screen for you to copy down. Okay. And question 3, example 3, a communications tower is some distance from the base of a 70-meter high building. From the roof of the building, the angle of elevation to the top of the tower is 11.2 degrees. From the base of the building, the angle of elevation to the top of the tower is 33.4 degrees. Determine the height of the tower and how far it is from the base of the building. Round your answers to the nearest meter. So if we were to draw this here, right? Let's just draw this. Boom, building. Boom, tower. Some garbage like this. I don't know. Make it, just make it work somehow. Doesn't have to be nice, right? Just make it simple. I'm going to have my building and my tower here. And it says, let's fill in the information here. So it says here, from the base of the building to the tower, it's a 70 meter high building. So this length here is 70 meters. Okay. the angle of from the roof of the building, the angle of elevation to the top of the tower. So I'm going to draw that here. So from here to here, it's saying that if we draw a kind of dotted line across to show the angle of elevation, right? It's saying that this angle here is 11.2 degrees. Then it says from the base of the building to the top of the tower, like this angle here is 33.4 degrees. And then it says determine the height of the tower. So determined this length here, which is h. Okay. And also determine here, this to here, which we'll call x. Okay. So you need to find x and you need to find h. This is the drawing that you should have. So I've drawn it for you, but you should get practice into how to figure out these drawings, right? So your homework check for tomorrow will be to do example 2 and example 3, right? We've done a bunch of these examples here, right, today. So I will post these notes on Google Classroom in like 5 minutes or so, and you may do so. Otherwise, if you have questions, you can stick around.